Good morning. Let us study today ionic crystals. What are called ionic crystals? In ionic crystals, the lattice array points are occupied by the ions. In ionic crystals, ions occupy the lattice points in space lattice or in unit cells. These oppositely charged ions, are held together by Coulombic electrostatic attractive force. These forces are very strong. Therefore, the amount of energy required to separate these ions are very high. Okay. Because of the above, ionic crystals have the following characteristic properties. Due to the above, the ionic crystals have the following characteristics. The characteristic properties of ionic crystals are as follows. Ionic crystals have very high melting point and boiling point. For example, more than 1000 degrees Celsius. Whereas the water boils at 100 degrees Celsius, ionic compounds have exceptionally high melting point, boiling point because of the electrostatic attractive force between the oppositely charged ions. Because of the high melting point and boiling point, they have less vapor pressure, whereas hexane, butane, they have high vapor pressure because of low melting point, boiling point. Because of very high melting point and boiling point, ionic crystals have less vapor. Okay, and ionic crystals have large heat of vaporization. It requires more heat to convert solid into vapor because of the high melting point and boiling point due to the electrostatic force of Coulombic electrostatic force of attraction between the opposite charged ions. Ionic crystals are hard. They are hard because the atoms or ions are fixed in lattice points, and ionic crystals are brittle. Why ionic crystals are brittle? Because when you apply force, sodium ion it flips. It flips. That is, sodium ion will be its neighbor chloride ion. When you apply force, sodium ion will come close to sodium ion instead of Cl minus ion. Therefore, Na plus ion and Na plus ion, there will be repulsive force. As a result, the ionic crystals become brittle. It is like a brittle like glass, okay, mirror. They are insulators. Ionic crystals are insulators in solid state because the ions are fixed, are not mobile. They are not free to move. Ions are not free to move in the solid state. Therefore, the ion the the ions are the carriers of electricity. There are no free ions to move. Therefore, ionic crystals are insulators in solid state. Ionic crystals are soluble in very much soluble in water, any polar solvents. But ionic crystals are insoluble or poorly soluble in non-polar solvents such as benzene, CCl4, etc. Hexane. When dissolved in water, ionic crystals, when dissolved in water, they become good conductors. Why? Because in water, the ions are free to move. The ions are free to move and to carry the electricity. Okay. The forces of attraction are inversely proportional to the dielectric constant of the solvent. As the dielectric constant increases, the force of attraction decreases. Okay. So, in the case of water, water has the highest dielectric constant 80. Therefore, the forces of attraction are very less. Therefore, they are soluble in water and are also they are they become good conductors. They become insulator in solid state dissolving in water, it becomes good conductors. Remember that. For example, sodium chloride and cesium chloride are examples of ionic crystals. The crystal structure of sodium chloride is shown here. The crystal structure, the structure is determined by X-ray diffraction by crystals. We have already seen. In this, there are sodium ions and chloride ions. Sodium ion, let us see first sodium ion. Sodium ions are present at the corners, 8 corners of the unit cell, cubic unit cell, and 6 phase center, and 6 at the phase center. The 8 corners are occupied by sodium ions, and the 6 phase centers are occupied by sodium ion. Therefore, it forms FCC array. Sodium ions form an FCC array. In the case of phase-centered cubic lattice, the ions are present at the corners and at the phase center. There are 6 phase centers. Now, how many sodium ions are present per unit cell? Calculate the number of sodium ions present per unit cell. There are 8 corners occupied by sodium ions. Each corner ion belongs to 8 other cubes. Therefore, each sodium ion contributes 1 by 8 only. Therefore, 8 into 1 by 8. Similarly, the atom at the phase center belongs to this cube and cube at the top. Therefore, half belongs to this unit cell, another half belongs to the other unit cell. Therefore, each atom at the phase center contributes 1 by 2 to the particular unit cell. Therefore, 6 into 1 by 2. There are 4 sodium ions present in the. Now, Cl minus ion. Cl minus ions are present at the 12 edge centers. There are 12 edge centers occupied by the anion, Cl minus ion, and at the body center. Cl minus ion is also present at the body center, edge centers. Each edge center belongs to 4 other cubes, 4 other unit cells. Therefore, each phase center, each edge centered atom contributes 1 by 4 to this unit cell. 12 into 1 by 4, 3, and the atom at the body center completely belongs to this unit cell. Therefore, its contribution is 1. Therefore, there are 4 chloride ions present per unit cell. So, there are 4 sodium chloride molecules in the unit cell. The crystal structure consists of FCC array of sodium ions, and the anions occupy all the octahedral holes. These centers are called octahedral holes. Center, body center, or octahedral are called octahedral holes. Okay, there are 4 octahedral holes occupied by the anion. Alternatively, suppose you consider here 3-dimensional extension, and this will come at the edge center. Now this will become phase center. Okay. Alternatively, the crystal structure is considered to be an FCC array of Cl minus ions, and the cations occupy all the octahedral. What is the coordination number of sodium ion or chloride ion? Each, for example, Cl minus ion is immediately surrounded by 6 oppositely charged sodium ions. Therefore, each ion is surrounded by 6 other oppositely charged ions. Coordination number of Cl minus is similarly, if you extend this unit cell, this will become body center, and therefore each ion is surrounded by, each sodium ion is also surrounded by 6 Cl minus ion. Therefore, the coordination number is 6:6. Okay. Cesium chloride is another example of ionic crystal. The crystal structure of cesium chloride is shown here. The structure is determined by X-ray diffraction by crystals. It forms and it forms a body-centered cubic lattice. At the body center, one cesium ion is present. The corners, the 8 corners, are occupied by Cl minus ions, as shown here. How many chloride ions are present in unit cell? Okay, so each corner atom contributes 1 by 8 to this unit cell. Therefore, 8 into 1 by 8 equal to 1. And there is one cesium ion at the body center. It completely belongs to this unit cell. It belongs to this unit cell fully. Therefore, its contribution is 1. Therefore, one cesium chloride molecule present per unit cell. Okay. The coordination number of cesium ion, for example, cesium ion, blue color, the cesium ion is surrounded by, immediately surrounded by 8 other oppositely charged Cl minus anions. Therefore, its coordination number is 8. Similarly, each Cl minus ion is surrounded by 8 other Cesium plus ions. Therefore, the coordination number is 8. Okay. One cesium ion is there. Therefore, one Cl minus will be there to make it neutral. Similarly, in sodium chloride unit cell, there are 4 Na plus ion and 4 Cl minus ion to make it neutral. Thank you for watching.